covering combined gas law. Combined gas law is basically taking a look at pressure, volume, and temperature affecting a gas. Before we get into that, I want us to go through this table and determine the state of each compound at 355 degrees Kelvin. Okay, so you're going to give it a code 1, 2, 3, depending on what state it is. I'll give you guys about 2 minutes to do that, and then we'll take it up. Okay, to do this problem, we need to be able to compare these temperatures in the same unit. So currently we have Kelvin. It makes more sense for me to convert this number here into degrees Celsius than to convert all of these numbers into Kelvin. So what I'm going to do is subtract 273.15 from this number, which will give me approximately 82 degrees Celsius. Now I have a number, and I can compare this number to the rest of my information. If the number is below the melting point, it is going to be solid. Okay, so let's make a little diagram here. We have our melting point. So if it's between the melting point and boiling point, it's liquid. If it is under the melting point, it is a solid. If it is above the boiling point, it's a gas. So now, looking at 82 degrees Celsius for H2O, liquid, solid, or gas? Liquid, because it's between the two temperatures, so that's going to be liquid. Nitrogen, liquid, solid, or gas? It's a gas. It boils at a negative 195 degrees, so it's a gas. Methane, it's also a gas. It boils at negative 162. 82 is much bigger than that. And lastly, we have ethanol. It would also be a gas. 2333. So the review question is asking us, tire pressure gauge reads 1,853 millimeters of mercury. Millimeters of mercury is a way to measure pressure to higher accuracy. We measure blood pressure with it. To ensure that the tire is at a safe pressure, it must be at 241 kilopascals. Does this tire need more air or less, or require air to be removed? So like I said, you need to put these two into the same unit. You cannot compare numbers unless you put them into the same unit. So you have to either have both be in millimeters per mercury or both be in kilopascals. Either or, it's fine. So I'm actually going to go ahead and convert this into kilopascals. So we're going to take this number here. So speaking of pressure conversion, yesterday you would have found that there are multiple ways to express pressure. 101.325 kPa is equal to 1 atmosphere, which is equal to 760 millimeters of mercury. This is inequality. Okay, they equal each other. From an equality, we can make a ratio. So the two units of interest that we are going to address here is kilopascals and millimeters of mercury. I'm going to convert the millimeters of mercury. So I start 1,853 millimeters of mercury. From there, I need to set up a ratio to perform unit analysis. So, because these two are equal to each other, I can create a ratio. I can say 101.325 kPa is over 760 millimeters of mercury. Or I can say 760 millimeters of mercury over 101.325 kilopascals. These ratios represent the same thing. The way they are set up is how we will perform our unit analysis. The units that you are looking for should always be in the numerator. We need to cancel out millimeters of mercury. So will I be using A or B? A. We're going to use A. So 101.325 kilopascals goes on the numerator, and 760 millimeters of mercury goes in the denominator. Millimeters of mercury cancels out, and you are left with kilopascals. In your calculator, you need to be plugging it in like this. 1,853 multiplied by 101.325 divided by 760. You are dividing because this number is in the denominator. Once you plug this in, you will get an answer of 247 kilopascals. We cannot stop there. That's not what the question is asking us. We need to go back and see what we're actually looking for. The question is saying, does the tire need more air or require less air? Are we above our goal or below our goal? Above. So do we need to add or remove? Remove. So we're going to say that the tire needs air removed. The tire needs air removed. Okay, so when you are in a test situation, I always want you to read the problem after you've done the math, just to make sure you are actually answering what the question is asking for. Some of you guys do this brilliant math, and then you don't actually end up answering what the question is asking you. The learning goals for today is we will understand the relationship of volume, pressure, and temperature in the combined gas law. We will confidently manipulate formulas. Okay, formula manipulation. We will be doing formula manipulation in this unit a lot, so I want to stay comfortable with the idea before moving forward. Here we have an equation, AB over C is equal to lowercase ab over c. So we are asked to isolate for this variable. Whenever you are asked to isolate for a variable, here's the first thing that I want you to do. AB over c is equal to AB over c. Get rid of your denominators. Denominators cause problems. The way that we get rid of our denominators is by multiplying. So on this side, I'm going to get rid of this capital C right here. So I multiply it by capital C. Whatever you do to one side, you must do to the other. So on this side, I also multiply it by capital C. Capital C and capital C cancel out on this side. We now have an equation that looks like this. AB is equal to ABC over C. I now need to get rid of that lowercase c. Same thing. I multiply that by lowercase c and this side as well. Okay. Now I have an equation that looks like this. CAB is equal to ABC. We need to isolate for capital A, this guy right here. So what I'm going to do is divide both sides by C and B. C and B. Cancels out on this side. A is equal to AB capital C lowercase c over capital B. Using the same equation, let's do it again. We have capital C we are isolating for this time. So A, B, C, oh, that's not the equation. Hold on. AB over capital C is equal to AB over lowercase c. Get rid of the denominators. It causes problems, so for now we will eliminate them. Multiply this side by capital C. Multiply that side by capital C. Multiply this side by lowercase c. Multiply this side by lowercase c. You now have an equation that looks like this. AB, hold on. AB lowercase c is equal to AB capital C. We are isolating this guy. So what do I need to do to get that variable by itself? Divide by AB. Divide both sides by AB. We cancel out on this side. Capital C is equal to AB lowercase c over lowercase a lowercase b. Okay, we're going to try it with one more equation. I'm going to do one with you guys, and then you will isolate for Q on your own. We are now isolating for capital B in this equation. AB is equal to Q capital M H. There are no denominators. There are no issues going on here. We need to isolate for B. So what should my next move be? Divide by A on both sides. Whatever you do to one side, you must do to the other. A's cancel out. B is equal to QMH over A. You are going to do B by yourself, isolate for Q using the same equation. Once you have isolated for Q, you should get the following. Q is equal to AB over MH. Combined gas law. In the combined gas law, we will explore the relationship between volume, pressure, temperature, with a constant number of moles. Okay, so we will have a constant number of moles. We will be manipulating one of the following variables: temperature, volume, pressure, or sorry, two of them, and one of them will be our responding variable. So you should have a box. In the box, let's put our combined gas law formula. This is how the formula works. P1 V1 over T1 is equal to P2 V2 over T2. Please write a capital T. Capital T means temperature. Lowercase t means time. So use the appropriate T. So this is one way to write the combined gas law. There is another way to write the combined gas law as well. So you can get rid of the denominator. So denominators, sometimes they confuse us. So another way to write the combined gas law is let's remove the denominator. So I multiply both sides by T1. T1 cancels out here. And that gives me P1 V1 is equal to P2 V2 T1 over T2. Let's eliminate that T2 because, again, don't like denominators. Multiply both sides by T2. T2 cancels out. The formula is P1 V1 T2 is equal to P2 V2 T1. So there's one way of writing it, and there's the other way. P1 V1 over T1 is equal to P2 V2 T2. These are representing combined gas law. Either one of the formula is fine. You will need to memorize this. Okay, you will notice that I will use the formula without the denominators just because it's an easier one for students to use. Feel free to use any. Let's do an example. A sample of ethane gas has a volume of 35 liters at 25 degrees Celsius and 100 kilopascals. The temperature is increased to 35 degrees Celsius while the pressure drops to 85. What is the volume of the gas? Okay, When you are doing this, I want you to list out your variables. I know that you guys think you can do this, but we're not ready yet. We're not ready for that step. Okay, even me, I need to list them out. So here's how you're going to do it. P1, V1, T1, P2, V2, T2. P1, my P1, what's my P1? This guy right here, this is P1, 100 kilopascals. V1, what is the initial volume of this gas? 35. This is my V1. Make sure you have your units on there. T1, right here. T1 is 25 degrees Celsius. P2, 85, it's right here. Kilopascals. V2, question mark, it's our unknown, it's what we are looking for. V2 is our unknown. And lastly, T2, 35. When you are going through your list of variables, you need to ask yourself, is temperature the correct unit? You need to have temperature in Kelvin when you are using any gas law formula. So to achieve that, we need to add 273.15 to this, which gives me 298.15. This one, 273.15. is equal to 308.15 Kelvin. Okay, temperatures in the appropriate units now. The next thing that you need to check, do my pressure units match? Yes, they do, so I do not need to make a conversion there. You have to make sure that your other variables, that their units match. Otherwise, they will not cancel out in the formula. What you put in is what you get out. Okay, let's move into the formula now. I'm going to scroll down. The formula that we will be using, P1, V1, T2 is equal to P2, V2, T1. Please be careful when you're plugging formulas in. We need to isolate for V2, this guy here. So what do I need to do to isolate for this? Divide by P2 and T1. That cancels. Oh, that does not cancel. That definitely does not cancel. Sorry, P2, V2, T1. T1 cancels, and P2 cancels. So the formula I get is V2 is equal to P1, V1, T2 over space. Oh, both sides. P2, T1 over P2, T1. No, order does not matter because you are multiplying. Okay, let's plug the values in. My P1 was 100 kilopascals. Multiply by 35 liters. This is where the biggest mistake is made. It says that you need T2 there. A lot of you will sub in T1. So make sure you are subbing in T2, 308.15 Kelvin. Okay, P2 is 85 kilopascals. And then you are doing T1, another place where a big mistake is made. Make sure you are appropriately reading what variable is needed. From here, you need to do unit canceling. Kilopascals cancel, Kelvin cancels, and you are left with liters. Does this make sense? Yes, we are looking for volume, so it makes sense that we get liters out. Okay, we are going to plug this into our calculator. Very specifically, this is how I want you to plug it in. In your calculator, you're going bracket 100 multiplied by 35 multiplied by 308.15 bracket divided by bracket 85 times by 298.15 close bracket. You need to use brackets, otherwise it will be wrong. Okay, so these two numbers here are multiplying by each other in the denominator. You need to communicate that to your calculator as well. If you leave this set of brackets out, you will get the wrong answer. So you need to have that bracket there. Once you plug that in, if you correctly plug this in, you will get 43. I want everybody to pull out a calculator, plug this in, and make sure you get 43. The biggest at SATP conditions, a gas has a volume of 40 liters. What is the volume of the gas at STP conditions? Okay, let's review a little bit. So SATP will provide us with a T1, a P1, and we have an initial volume of 40. Then we move the gas to STP conditions, which gives us a T2 and a P2. Okay, and we are looking for V2. Let's list out our variables. P1, V1, T1, P2, V2, T2. Does anybody know what the temperature at SATP is in Kelvin? 298.15 Kelvin. Does anybody remember what pressure is at SATP conditions? 100 kilopascals. 40 liters. Does anybody know the pressure at STP conditions? 101.325 kilopascals. V2 is what we are looking for. T2? $273.15 Kelvin. We are looking for volume. Yes, you will need to know SATP and STP conditions. Okay, so let's make our formula. P1 V1 T2 is equal to P2 V2 T1. Again, we are looking for V2, so we are going to isolate for this variable by dividing by P2 T1 on both sides. This cancels out, this cancels out. We have now isolated for V2. V2 is equal to P1 V1 T2 over P2 T1. Let's plug in our values. P1 is 100 kilopascals. V1 is 40. T2, okay, again, very common place where mistake is made. T2 is 273.15 Kelvin divided by P2, which is 101.325 kilopascals, multiplied in the denominator by T1, which is 298.15 Kelvin. From here, you need to make sure that your units cancel out. Kilopascal cancels out with kilopascal. Kelvin cancels out with Kelvin, and we are left with liters, which makes sense because we are looking for volume. I want you to take a moment, plug this in, and you should get an answer to the correct significant digits, 36.2 liters. Take a moment, plug that into your calculator. Example 4 is weighing out the proportions in the formula. So it looks a little chaotic the way that it's worded. It's saying what factor will temperature change in Kelvin if pressure is doubled and volume is tripled? So I know this is combined gas law because I'm working with the following variables. Temperature, which is in Kelvin, pressure, and volume. Here's how I want you to set up these sorts of problems. You're going to start by listing your variables. P1, V1, T1, P2, V2, T2. The best way I can recommend of doing these sorts of problems is by using the formula. From here, you're going to select numbers for your P1, V1, and T1. My recommendation to you is to select 1. So I'm going to say that my P1 is 1 kilopascal. My V2 is 1 liter. And my T1 is 1 Kelvin. Okay? The reason why I say choose 1, it's the least complicated number for you. You can choose 1,000. You can use 24.6. But you're going to make your life complicated. So choose 1. What happened to pressure? It doubled. So this number here doubled. That means we multiplied it by 2. So now we have 2 kilopascals. What happened to volume? Tripled. So this number here multiplied by 3 gives me 3 liters. We are now looking for T2 because we're looking for the change in temperature. We're looking for this connection here. We're looking for the factor it is multiplied by. Okay, let's use our formula. P1, V1, T2 is equal to P2, V2, T1. We need to isolate for T2, so I'm going to divide both sides by P1, V1, P1, V1. On this side, pressure cancels out, volume cancels out. T2 is equal to P2, V2, T1 over P1, V1. Let's plug in some numbers. Notice how P2 is on top. Please, please, please make sure that you are matching your variables to the actual numbers. So my P2 is 2 kilopascals. My V2 is 3 liters. Multiplied by T1, which is 1 Kelvin. Divided by P1, V1, which is 1 kPa. Multiplied by 1 liter. 1.0 liters. Let's do a unit cancel. Kilopascals cancels out with kilopascals. Liter cancels out with liters. And I end up with a T2 of 6 Kelvin. Now you go back here. This is 6 Kelvin. So for me to get from 1 Kelvin to 6 Kelvin, what did I multiply by? 6. So I multiplied by 6. Again, you need to answer what the question is asking. It's asking what factor will temperature change by? Temperature changes by a factor of 6. Do we understand? Okay, I'm going to help you guys set up example 2, and then you guys can try it on your own. It says a 3-liter sample of gas is held at 298 Kelvin at a pressure of 230 kilopascals. What will the volume of the gas be if the pressure drops to 100 kilopascals? Did it say temperature changed? No, temperature did not change. So your T1 and your T2 are equal. It is constant temperature. Okay, so I will set this one up for you, and then you can check your answer after. So P1 is equal to 230 kilopascals, 3 liters, 298 Kelvin, P2 is 100 kilopascal, P2 is our unknown, and T2 is constant, so it is. Okay, so this one is a constant temperature. Therefore, T1 is equal to T2. Once you're done plugging it in, you should get an answer of 6.90 liters.